Right. So today we're going to start chapter 10, and I just want to refresh our memories what we did a couple weeks ago on chapter 9. So in a couple weeks ago, we learned how to estimate the population proportion, P, or how to estimate the population average, mu. And we used confidence intervals to do that. Now, and that was a type of inferential statistics. Now in chapter 10, we're going to continue with a type of inferential statistics, and this is called hypothesis testing. So we're going to start with some definitions and some new notation, and I'm going to talk about it. We're going to talk about this chapter for the next few weeks.
Did you post these notes yet? I didn't see them on my courses.
I did not. I'm hoping to post our notes. So, but they will be posted. When we talk about hypothesis testing, we have a 5-step process. And what we're going to talk about today are the first 2 steps. And the first 2 steps are called the population step and the method step. Okay, so those are the first 2 steps we're going to look at. So first, let's talk about hypothesis and the idea of the testing. So a hypothesis is an idea or a theory. A hypothesis test is used to determine if sample data provides sufficient evidence to support a new idea and disprove, or what I call reject, a common view. Okay, so I call it reject the common view. So a hypothesis test, sorry, I just bumped my chair. A hypothesis test, we're actually testing to see if we have evidence to support this new idea. And we want to reject this common view. So I need to show you some notation for this, okay? And we're going to use everything we've been talking about these last few chapters, especially with probabilities and all that. We're just not going to get to that today. So what I want to introduce to you is new notation, which is H naught. So it's H with a little subscript O or 0. So I'm going to write what that is. So we know how to say it, H naught. H naught is what we call the null hypothesis. And the null hypothesis is my common view. So it's what people already think. And this common view is assumed true until evidence indicates otherwise. And what we need to know about this, the null hypothesis, H naught here, this is the center of the curve. This means something to us, right? And if it doesn't, it really should. Because the last 3 chapters, we've been looking at these curves and we need to know the center, right? If we don't have the center, we're kind of lost. My null hypothesis is the center of the curve that we're going to be looking at. Don't worry, I'll show you guys some pictures here shortly. Not that I'm an artist, but we'll see. I want to show you a couple ways that we can view the null hypothesis, how we're going to write it. Now, these are 3 different ways. You don't write it the same way all the time. It depends on the problem. So one way could be that we have the null is equal to some value, or the null can be less than or equal to some value, or the null can be greater than or equal to some value. So what you need to notice is that all of these include the equals. So the null hypothesis always includes the equals. So even if you're writing it as a less than or greater than, it's less than or equal, greater than or equal. Okay, so it always includes that when we're looking at the null hypothesis. Now, the other hypothesis we're looking at is the new idea. So right here, if I look at my hypothesis test, I'm looking for evidence to support a new idea. This is called my alternative hypothesis. And the notation for this one is HA. And we might see it as HA, or you might see H1. Like this. Let me write it like this. H1, there. I always write it as HA, so you know. I never refer to it as H1, it's always HA. And the reason why it's HA, it's because this is the alternative hypothesis. This is a new idea. And this is a statement that we are trying to find evidence to support. So everything is about supporting this HA. I'm trying to find evidence to support this HA and to support that alternative hypothesis. So I'm going to show you directly below these null statements here. I'm going to show you directly below for my HA. Just keep in mind, the alternative is the new idea, and it's exactly opposite of the null hypothesis, the common view. So if the common view is equal to a value, then that means that my alternative would be not equal to that same value. And I'm going to show you examples. Or if my null hypothesis is less than or equal to a value, then that would mean that my HA is greater than that value. Okay, so they're just exactly opposite. Or my null hypothesis is greater than or equal to, then my alternative is less than value. Okay, so they're always opposite. I want you to notice the null always has the equals and the HA never has the equals. Okay, it's just a not equal, greater than, or less than statement. So I'm going to show you these steps, and then I'm going to show you some drawings about what these look like. Maybe, if I could separate my paper out here. So the first step is the population step. We've seen something like this before, we've just never really talked about it. So you've seen this on your team assignments. The population step, it's just describing the population that we're studying, okay? Not the sample, the population. So the first thing are the objects. So the objects are like the who, right? So the objects are all individuals. Now, I want you to know, this is not all individuals in the sample. This is all individuals that we're going to project. So in the population. So the example we're going to do today is about RIT students. So yes, we might only sample 100 RIT students, but the population, the objects are going to be all RIT students. You see what I mean? So it's all of that group, not just the few that I actually asked the question. So it's about the population, not the sample. The variable. So remember the variables, what changes from individual to individual. So this is like my what. So what is changing, right? So if it's numerical, it might be like the average on the test that we just took, right? That changes from person to person. If we're talking about a question like, is your favorite ice cream chocolate ice cream? That's a yes, no question, right? But that still changes from person to person, how they answer a question. So when we talk about our variable, this is our what. So it's what's changing from person to person. We want to make sure we make a note. Is this numerical or categorical? We want to make a note of that, numerical or categorical. Now, if you remember on some of the team assignments, I'll say, well, who are the objects we're studying? And what is the variable? And is the variable numerical or categorical, right? So we've already been doing this, just maybe not listing it out in the same way. The rest of this problem is going to be driven by what I have here. So it's so important for us to know if we have a numerical data for a variable or if it's categorical data. It's so important for us so we can move forward. So right here, the very next thing is unknown, which this is new, but it's not. It's just a new name. I want you to know, I want us to talk about what is the unknown. Well, think about this. We're talking about inferential statistics, meaning we have a population mean that we don't know, right? We have a population proportion we don't know. It just depends if it's numerical or categorical. So if it's numerical, it's the mean. If it's categorical, it's the population proportion. So here, our unknown will be mu for numerical data. Or it will be P for categorical. So I will know this, I'm gonna put an or here, right? It's one or the other. So I need to state the unknown, is it mu or P, and then I'm going to define it. So then define mu or P, whichever one it is. That is our unknown. So we don't know the value of mu or P, but we can define what mu or P stands for. And when we do that, you'll see in the example, we define it by using the objects and the variable. So if you do a good job writing the objects and writing the variable, you can put them together. It's like you marry them together to define your unknown. And it's really nice. It works out really nice. It just flows. It's really nice. Then the last part to this first step is the goal. So I want to state, what is my goal in the end? Well, if you remember what the hypothesis test says here, it's used to determine if sample data provides evidence to support the new idea or disprove, and disprove or reject that common view. So I want to find data to support, or I want to find evidence, I'm sorry, our data is our data. I want to find evidence to support that new idea. So right here for my goal, I'm going to say to find evidence to support the alternative and reject my null. Now, it's not two different things. This is one and the same. So if I'm rejecting my null, I'm finding support for my alternative, okay? So it's not like I have to do two different things with the and, it's just they're one and the same. I'm not going to write it when I do my problems. I'm not going to write it just HA and H not. I am actually going to write it out in words, and I will define it based on the problem. And I'm going to show you how to do that. We might not get through it today, and if we don't, that's okay. We'll get through it tomorrow, or Wednesday rather. Let's talk about the next step. So we're going to talk about the first two steps, so population, and then the next one is method. You're going to notice that each of these steps have 4 parts to them. The method step, I'm going to define my null hypothesis. Now I want to write out what the null hypothesis could be for different scenarios and for numerical and categorical data. So my null hypothesis, if it was numerical data, it would be mu is equal to some value, or mu is less than or equal to some value, or maybe mu is greater than or equal to some value. And I'm going to write ors in between these because it's only one of them. It just depends on the problem. So or here, okay? It depends on the problem. And really, it depends on my HA. So almost all the time I have to write my alternative first, and then my null comes from the alternative. Let me show you what this looks like for categorical data. It would be the same thing. P is equal to some value. P is less than or equal to some value. P is greater than or equal to, oh, I'm sorry, not the equal to. Oh, yes, it is, sorry. The equal to, the value. I'm getting confused here, am I? Confusing myself. My alternative now, okay? Like, write my ors in here. My alternative, now my alternative doesn't have the equals involved. Now I'm going to write the same thing and write it in the same order. So the first would go with the first down here, okay? Because they're the opposite, right? So for numerical data, it would be mu is not equal to some value. Or it would be mu is greater than some value. Or mu is less than some value here. Okay, and that's how we would write them. Or I would have P is not equal to some value. Or P is greater than, or P is less than some value. Right, the or is in between, so we understand it's only one. So I only have one thing for my null and one thing for my alternative. These are just the differences, right? So categorical and numerical. Okay, so that's how I'm going to write my null and my alternative here. So those are the first 2 parts for my method step. Now the next thing is alpha. Alpha, remember alpha here, let me write it. Alpha is the same thing as it was in our confidence intervals, chapter 9. It's the area and the tails, okay? I'm going to talk about alpha here in a minute, but we just want to state what alpha is. It will be given to us. And then lastly here, I want to state what curve we are in. So remember that we have 2 different curves now. If we're talking about numerical data, the curve that we're using is the T curve. We talked about that a couple weeks ago, we learned that. And remember the T curve, the shape of that curve depends on degrees of freedom. So I want to make a note of degrees of freedom is equal to n-1. Or if I'm looking at categorical data, then I am on the Z curve. And remember, the Z curve does not change shape. It is the same shape all the time, and it's just my standard normal curve. So I don't need to make any notes about n or anything like that because it's just the same all the time. So this is my method step for my numerical or my categorical data. All right. So I told you a lot from the population that variable. I need to know that. So I want to go over these 3 different ways how you can write these, right? The the null and the alternative, and the shape, what it looks like. We have 3 ways. And you'll know how to set these problems up because it'll be in the wording. So the first scenario is when we have the null and it's an equals. And then that means the alternative would be a not equals. Now, the shape of the curve, it's not the shape, it's always normal, but where the tail is and the area in the tail, that alpha we're talking about, is based on my alternative, okay? So when this one says not equals, that means it's what we call a two-tailed test. So that means I'm looking at the area in both of these tails. Now, alpha is the area in the tails. If I have 2 tails on one curve, it's just like a confidence interval, then it's alpha divided by 2 in each tail. Now remember what I said in the beginning, the center of my curve is my null hypothesis. So this is what we call a two-tailed test. We're not going to do much with this at the moment, today's class, because we won't have enough time. We'll be working on this going forward. We will need to know what this looks like. So just know it's like a CI where it's centered, right? So the middle, it's centered. The tails have the same area in them. It's not like one is 25% of the area and the other one's 75, okay? It's equal. So it's alpha divided by 2 on both of them. Just gonna draw these lines to separate it out. The next one is where I have my null is greater than or equal to some value and the alternative is less than some value. Now remember what I said about the alternative that drives us to know where the tail is here. So now I'm looking here for the less than, that's the left tail, and that's where my alpha is. So the area in that tail is just alpha because I only have one tail. So this is called my left tail test. And remember, this is still the null hypothesis is the center here. And lastly, we have where the null is less than or equal to some value and that alternative is greater than. So if the alternative is greater than, then that means we're looking at this right-tailed, okay? My center is still my null. This is right-tailed test, okay? The area in the tail is still that value of alpha, like we talked about before. I want to tell you a little bit about alpha here. I just want to maybe not have these lines. Just wipe these out real quick. Okay. So about alpha. So alpha, we know is the area in the tail, but alpha is what we call the level of significance. This value alpha is what's going to tell me if we have support for the HA and to reject the null hypothesis. So this is what's going to tell me if I have support or not based on my sample for the alternative hypothesis and to reject the null hypothesis. We just won't know it yet because we're not going to do that until probably next week. Okay, so just keep in mind this is the area in the tails. And alpha is equal to 0.05 most of the time. So alpha, the area in the tails, is 5% most of the time. So if it's a two-tail test, it means 2.5%, right? If it's left tail, it's 5% here, right tail, it's 5% here. So it's 5% most of the time. And then once in a while, we will see alpha is equal to 0.01. And this is going to be for a medical problem, or what we would call like life or death problem, okay? So the reason for that is we don't want to disprove a common view very easily for a medical or a life or death situation, okay? So we lower our level of significance. We bring it down to 1% compared to 5%. Now I just want to make a note over here, back on my method step, here, when we have alpha, so most of the time, alpha is equal to 0.05, or we will see alpha is equal to 0.01. Now, you will be told this value, okay? It will be given to you. It might say level of significance is 5%. You know it's 0.05. Or maybe it's 1%, or maybe it's just something different than that. It doesn't have to be those two. It's just those are the most common. The only time I'm not going to tell you is on a team assignment. I might not tell you. But if I don't tell you and we're on a team assignment, then you just figure it out. If it's just general problem, it's 5%. If it's medical, life or death, it's 1%. If you're talking about something with heart attack patients and you say, you know what, it's life or death, I'm going to choose 1%, I would agree, okay? The only time I'm not going to agree is if you have like a pizza delivery problem and you tell me that's life or death, it's medical, and you say it's 1%. I might say, I don't think that's life or death for most people, okay? So, but on an exam or anything like that that really counts, I will give you that alpha value. It's not a guessing game, okay? Let's take a look at an example. We don't have too much time. Okay, good. So let's take a look at an example and we'll see how far we can get. If we can't get through the example, it's okay, because I'm going to carry this example through the next few classes, because as we learn a new step, we're going to apply it to the same example, and I'll add other examples in as well. So for this example, it's about RIT students. So it is commonly thought that a small percentage of college students approve of the university's administration. Okay, the RIT professor wants to convince the campus community that, more than 67% of RIT students approve of the university's administration. Okay. So this is the problem we have. Now, when we have this type of problem for chapter 10, which is hypothesis testing, you're going to get another chunk of information down below, and it will be information about a sample, right? A sample that was done. So maybe so many RIT students were actually asked this question. So we actually, surveyed some people. We don't need that for these first two steps, for the population and the method step. We don't need that piece of information. So I'm not going to give you that until next class. So next class, I'll give you that piece of information. So that's why we don't have it right now. So let's take a look at what the population is going to look like here. So we have to read through this and pull out all this information. You can underline things, you can write them off to the side, but I have to write them out anyways. So I'm just going to kind of read through it and write it out as I see it. So the first thing, the objects. So I already mentioned this before, but the objects are all of the individuals in this population. So what are we talking about? We're talking about how RIT students approve or disapprove of, approve or disapprove of the university's administration, right? So the objects, these are the people we're studying. These are people that we're going to ask the question. This is going to be all RIT students. So you should just get used to writing all in front of whoever it is that you're asking a question to, all of them. It's not just the 50 in the sample or whatever it is. We don't have sample information yet. It's all of them. So you should just get used to it. Every time you write objects, all of whoever it is, okay? Remember, objects are who. Then we're going to look at, and we want to write out what the variable is. So this is like the question that's being asked. This is what changes from person to person, right? It's their response to their question, really. So a lot of times with a variable, if it's numerical data, it's really easy. So like it could be age, right? So say we're asking someone their age, and I'm going to ask people, what is their age right now in months or whatever it is. And so a variable, if it's numerical, you can just say age. Like it's very simple. Categorical, it's sometimes harder to put into words. And if that's the case, just write the question that you're asking the people. So here it says, RIT professor wants to convince the campus community that more than 67% approve of the university's admin. So that's the question I'm going to ask. Do you approve of the university's admin, right? So I'm just going to say that, do they, or do the students, or do you, any way you can write it. So do they approve of the university's admin? And this is a yes, no question. This is categorical data, right? I need to make a note. I want to be able to say this is categorical data. So make sure you write it all out. Do they approve? Or you can say the variable is their response to the question. Do they approve of the university admin? Whatever, how you want to write it. I normally write it like this, and I know, okay, it's categorical. It's a category someone fits in. Either they do approve or they don't. Right? Okay, my unknown. So now if I know this is categorical, I know what my unknown is. Categorical is all about proportions. It's all about P. So P is unknown. And what is P? P is the population proportion. So that's how you should always start this out. P is population proportion. Now I have to say what it is of. It's of the objects in the variable, right? So it's the population proportion of RIT students. I'm just going to take it right from above, who approve, because that's what I'm interested in, of the university's admin. That's my P. P is the population proportion of RIT students who approve of the university's admin. So you don't have to write it exactly the same way as me. You could say something like, P is the proportion of all RIT students. All would mean population. All would mean everyone in that community, okay? And then the same thing. Or you could say P is the true proportion. True would be the same thing as population, okay? True meaning all of them. So you can write it whatever way you want. Just know I need to see either all, population, or true with proportion and your context, your variable and your objects. Okay. All right, then lastly is my goal. It's really hard to write a goal for us. We're new at this. So for us, I'm gonna just say, well, I'm gonna leave the goal right here. And this, I'm just gonna leave it very simple: to find support, to say, and then I'm gonna leave it blank because I don't know what HA is, because it's to find support for HA. But I don't know what HA is saying because I don't know what it is yet, because we're new at this. So I'm gonna set it aside. I just need to remember to come back. So I'm not gonna fill out my goal just yet. I do this a lot in Stat 1. If you can do it, then go for it. That's awesome. If you can't, don't panic. We're just gonna go back to it. So I'm gonna start my method step, and then I can go back to my goal. So I just wanna make a note here. My method step says this professor wants to convince the campus community that more than 67%. That's what he wants to convince. It says the common thought is it's small. It doesn't give me a number, and that's okay. Remember, I normally write my HA first. I mentioned that. Here's my number. So here I have my null and my alternative. I'm actually going to write the alternative first. So since we're talking about categorical data, it's P, and it's whatever this says that this person wants to prove or convince, more than. So P is more than, greater than 67%, which I'm going to write it as a decimal, 0.67. Write it as a decimal because we're going to be working with numbers, calculating probabilities, that kind of thing. So it just makes more sense to write it as a decimal right away. Now, my null can be written exactly opposite. So P is less than or equal to 0.67. So it's very simple to skip that second one once you have the first one. I do want to make a note to you. I'm just going to write or here. P can be written as an equals 0.67. This can always take place. So you can write them, and most of the time it's just easier for us in Stat 1 to write it this way, where I have my HA, then I write my null exactly the opposite from my HA. But I want you to know, you can always write your HA as a greater than and write your null as just plain equals. You're gonna see this probably on your homework, and it's okay. I know in algebra and calculus, these don't mean the same thing, and they don't necessarily in stats all the time, but here with hypothesis testing, they do mean the same thing. I'm really sorry for that. I think sometimes that's confusing for us just starting out. I like to make a note of this because it will be on the homework. Although you'll notice you don't have any homework for like the next week or two. And that's because the book goes through hypothesis testing in a different way than I go through it. So we need the couple weeks, which I'm sure you guys won't complain about not having homework for a couple weeks. So that's my method and my alternative. Then we have our alpha. Alpha is not given to me, but this I don't think is a life or death medical situation. So I'm gonna go ahead and say alpha is 0.05. So it's 5%. I'm just writing it as a decimal again, because like I said, we're going to be computing probabilities and using these things. It's easier to keep everything in decimal form. Then I just want to mention what curve I'm on. I'm studying categorical data. These are P's. This is going to be my Z curve. That's it. I don't have to state anything else. I don't have to draw it, nothing. Just say I'm on my Z curve. So the method is really quite short compared to the population. I'm going to go back to the population real quick for us. So here the population says the goal is to find support to say. Now remember what we said before. I don't know if I can find it. Yep, right here. To find evidence to support the HA. That's what I want to write for my goal. I don't have to say to reject the null. I can just say to support HA. So I need to, instead of writing to find support to say P is greater than 0.67, I want to write it out in words. So I want to write it out in words, and good thing I've already defined P up here. So I'm going to write the definition of P and say it's greater than 0.67. So I want to find support to say that the population proportion of RIT students who approve of the university's admin is greater, or you could say more than 0.67. You can even write 67% if you want right there. It doesn't matter. I just normally stick to the same thing because then it's just simple. I'm not switching back and forth. Not that it's hard to switch back and forth. 0.67, 67%, but it's like less mistakes, right? So I just took what we have here for our HA and I plugged it in here with words, not symbols. And that's what I want you to do. So this is my whole population step. I can't get it all on there, but you guys can see that, okay? And our whole method step right here. So the method step is quick. This is the longest part, getting the HA from the reading, and then you write your null from the HA, alpha you pick right up in the reading, and Z comes from the type of data we have. There.